Today I have a tough simplification problem for you to try, so let's get into it. So we have the sum of 1 over the cube root of 1 plus the cube root of 2 plus the cube root of 4 plus 1 over the cube root of 4 plus the cube root of 6 plus the cube root of 9 plus 1 over the cube root of 9 plus the cube root of 12 plus the cube root of 16. All right, so we want to simplify this, and this looks really tedious to do, right? Rationalize all the denominators, blah, 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 but there's a much better way to go about doing it. And let's start with writing it all like this. We have 1 over the cube root of 1 squared, right? Because 1 is the same thing as 1 squared, plus the cube root of 2 times 1 plus the cube root of 2 squared. All right, then plus 1 over the cube root of 2 squared plus the cube root of 2 times 3 plus the cube root of 3 squared. Then only one more, 1 over the cube root of 3 squared plus the cube root of 3 times 4 plus the cube root of 4 squared. All right, so now we have this. And this doesn't look quite too helpful yet, but it's super helpful for us solving this. Because what do we know? Well, we know a cubed minus b cubed is equal to a minus b times a squared plus 2, it's not 2, plus ab plus b squared, right? We can take this, and what can we do with this? Let's rearrange it. Well, we'll rearrange this to a squared plus ab plus b squared is equal to a cubed minus b cubed over a minus b. And then lastly, one last rearrangement, right? And we'll do it over here, save room. We get 1 over a squared plus ab plus b squared is equal to a minus b over a cubed minus b cubed. All right, so we have this. And how can we go about using this? Well, let's look. Every single one of our things in the denominator are in the form a squared plus ab plus b squared, right? And there's the cube root, but that's okay. It still holds. So we can take each one of these, right, where in this case, a is 3 and b is 4, and we can turn them into this form right here. Or sorry, a would not be 3, a would be the cube root of 3 here, and b would be the cube root of 4 there, right? That's an easy mistake to make, is thinking that a is 3. A is not 3, right? Don't make that mistake. So then we can take it, and we go down here, and a minus b on the top. So we get the cube root of 1 minus the cube root of b, here's the cube root of 2. Then over b a cubed, right, is the cube root of 1 cubed. That's 1. 2, the cube root of 2 cubed is just 2, right, minus 2. Then plus, and we get, here we have the cube root of 2, right, minus, then we have the cube root of 3, Then we have cube root of 2 cubed, which is 2, minus cube root of 3 cubed, we have 3. Then we just do that one more time, and we get cube root of 3, right, minus cube root of 4 over 3 minus 4, right? I encourage you to check that that's correct. Then we see that each one of these will be -1, so we can factor out a -1, but we'll also see that this will cancel out with this, right? And this will cancel out with this. So we'll have -1 times the cube root of 1 minus the cube root of 4, right? And this is just equal to the cube root of 4 minus 1. And that's our simplification. Thank you for watching. Let me know if I say anything wrong or if you have anything additional to add. Have a great day.